Okay, hi everyone. Today we're going to look at, we're going to continue with chapter 8 percentages, and we're going to start off with what we left from the other day. So actually, this over here is actually the questions that we left from our previous lesson. So we have actually two questions compiled from three different practice now from your textbooks. So you have your first part, which is to convert your percentages to fractions and decimals. Second part is actually to convert fractions and decimals to your percentages. So just a recap is actually from percentage to fraction and decimal, it's just to divide by 100. Take the value of 76, divide by 100 is a percentage, 95, simplest form. Multiply by 100%. Just take the fraction 600 and leave the percentage. Okay, so I'll give you a minute or two to write down what is going on here. At the same time, what I would like you to do is to just check through your answer and take the 1 to 2 minutes check through your answer and write down all the necessary. Okay, so yeah, once you're done, you may turn your textbook to practice now 3. We're going to go on to the next concept. Okay, so please pause your video and then we will see you at the next screen. Okay, so pause in 3, 2, 1, okay, go. Okay, so I hope you are back. Now, what I want to do is let me bring Okay, so the first thing we will see here is actually thinking time. Oops. Okay, thinking time from, I think, page. Which page is it? Page. Okay. Can't find the page number. Okay, anyway, thinking time from page 5. Okay, so here. So what's going on with this thinking time is they claim that we can change any fraction decimal into a percentage by multiplying with 100, which is what we did over here. Okay, and but we cannot just multiply it by 100 and explain why is this so. And the thing that they gave was P over Q is equals to P over Q times 100%. But if it's P over Q, it does not equal to P over Q times 100. And why is this so? Even though we actually, ignore the percentage sign and leave the percentage sign there. Now, why is this so? Because this one over here, P over Q is equals to P over Q times 100%. Okay, now what does this mean? Is actually, this thing actually it means 1 over 100. Sorry, not the 100. This percentage sign. Okay, this means 1 over 100. Okay, so this one is actually okay. Right, this is okay. Alright, so when we have this, right, because it prevents our because it preserves, right, our equivalence. Multiplied by 1 over 100. So overall effect over here, okay, overall effect over here is just to multiply by 1. So when you multiply by 1, it doesn't really change anything. So it really preserves that equivalence. Okay, so that's why when we write down the notation, right, we actually put in the percentage sign and then we leave the percentage sign there so that it tells us that okay, later if you want to convert back, you need to times the 1 over 100. Okay, so this way we really can preserve the equivalence. So it's actually equivalent. If without the percentage sign, it's just multiplied by 100. So it means that it's not the right way. Means that you get a bigger number without the percentage sign. Okay, so this is all for taking time. We're going to look at the next one, which is your practice now 3. Okay, now so for our practice now 3, okay, so in page 7, okay, so yep, practice now 3 over here in page 7. Now, so let's look at the question. So what we're going to do today is actually a lot of the primary school things. So I'm just going to do everything in one shot and just jot down your memory. Okay, alright, so practice now 3, we have 50 cards in the set. Okay, 18 cards are red while the rest are blue. So if if 30% of the cards have a number printed of them, find the number of cards that do not have a number printed. Okay, so very straightforward. We're going to start off with like writing down the statement and analyzing. You don't have to write this though. I'm just going to write this down and like analyze this. So if 30% is printed, since we're looking for the cards that are not printed, so I'm just going to calculate. So 30% printed meaning 70% not printed, because it's the whole is 100%. So 100 minus 30 gives you 70%. So 70% not printed, right, means and we're looking for 70% of the 50 cards. So 70% of 50. So instead of I'm just going to write times 50. Okay, so actually this one, if you press your calculator, this would be actually 0.7 times 50. And actually this one is 35 cards. So what we want is actually 35 cards over here. Okay, for part A. So 35 cards do not have a number printed. Now for part B, if 75% of the blue cards are laminated, find the number of blue cards that are not laminated. So we want to find the not laminated. So now there's 2 ways to do this. This is the longer way. Okay, so the 75% laminated, right, means that the one that we're looking for not laminated is 25%. Okay, so let us look at and then they say that is the number of blue cards. Okay, number of blue cards. So then we need to look for the number of blue cards first, or actually a easier way to write this out. Okay, so this sign actually means like the number of. Okay, why they use this? Because like back in the 90s, when they say give me a number, like they use the hashtag. Okay, so this hashtag means the number of. Okay, so I'm just gonna write this number of blue cards. Okay, so number of blue cards is just 50 cards minus 18, so I have 32 blue cards. Okay, so 32 blue cards. So then the number of blue cards not laminated okay, so this is 25% not laminated, right? So 25% of 32 times 32. So this is actually 25% is 0.25 or 1 over 4 times 32. So this will be equals to 8 blue cards which are not laminated. Okay, so there you go. Now the alternative working is actually like this. If you want to combine everything to one statement, can we just look for the number of blue cards not laminated, right? Okay, so what we need to do is we need to find the 25% of. Okay, so blue cards is just 50 minus 18. So straight away you can do your calculation in one shot over here also can, if you know it. Okay, so here you can actually come to it, it's just 8 blue cards also. Okay, so it's just a combination of 2 steps into 1 step. Okay, so you can do this, no issue, there's no need to split it up nicely. And take note in question B, because there's a multi-step part, so what I did is actually to label and write down these statements over here. okay, to tell you what am I calculating. So this one I really urge you to do the same as well. You really need to write down all these side statements, okay, in order to make your things clear. Otherwise, if I were to look at just 50 minus 18 is 32, then 25% times 32, yeah, it may not be what you're looking for. Okay, so really I urge everyone to write down the side statements to really make your presentation clearer. Okay, now let's look at the next one in question 2. So question 2 is just to find out the value of each of the following. Okay, so question 2. Now 2a, very simple, we are looking for 2.5% of 30 cm. Right, so 2.5% is simply 2.5 over 100. Of means times 30 cm. So this one, I just need to do some quick calculation over here. So 2.5 divided by 100 times 30. Okay, so here I have 3 over 4, so 0.75 cm. Okay, next for B. Okay, I'm looking at 15 and 3/4% of 640 kg. Okay, so what I need to key in is 15 and 3/4, okay, over 100 times 640 kg, right, like this. Okay, so my calculation would be 15 and 3/4, so 15.75 over 100 times 640. Okay, so let me write. See, okay, 100.8. Okay, so 100.8 kg. Okay. Now, last but not least, the part C. It is 2,500% of $4.60. So it's going to be bigger than this, huh? So 2,500 divided by 100 times $4.60. Okay, so this will give me is just 25 times 460. Okay, so this is 115, so $115. Okay, so here we go with practice now 3. Okay, we're going to look next for work example 4. Okay, so give me a while to swap this up. Okay, now in work example 4, okay, let me write down some things over here. So work example 4. Okay, so work example 4 is kind of a new thing though, because it appeared quite recently in like we call this like reasoning questions, like to ask why and so on. So yeah, so the question goes like this. So Bernard was asked to find the value of 250% of $100, and his answer was $25 without performing any calculation. Explain to Bernard why his answer is incorrect. So what happens is, so why is he incorrect? Because 250% usually is bigger. Okay, it's 2.5 times of 100. So I think you can see like that yeah, so what you can do is you don't have to do a lot of calculation. You just have to like make sense of this. So 250% of $100, okay, should be larger or should be more than 100%, because like no, $100, because 100% is like itself the whole thing. So 200% means like double of the thing. So if you can see that way, so you can say that the $25 is incorrect. Okay, now in the same vein, let us look at the next question over here, which is so Wei Ming was asked to find the value of 3.6% of 100 kg, and his answer was 3600 kg. So 3.6% means like it's a smaller value. Okay, instead of 3.6 times 1000, it should be 3.6 over 100 times 1000. So actually here, practice now for same page. Okay, so we can reason that 3.6% of $1,000 should be less than, okay, right, so should be less than $1,000 itself. So the answer, right, so the $3,600 is incorrect. Okay, like this. Okay, so the reasoning will come like this. So you don't have to do fancy calculation for this kind of question. Just need to like use logic and to reason out. Okay. Alright. So next we're going to jump straight ahead to practice now 5, which is the next page. Okay, just let's practice now 5. Okay, practice now 5. Okay, so before we go on to practice now 5, right, I want to write down something here. Because now we are going to calculate the percentage of one quantity over another quantity. So more often than not, right, so the required percentage, okay, so usually the required percentage, right, okay, will be equals to, now it would be the number, okay, number of things that we want to find out over the number of stuff that we are referring to, okay, times our 100%. Okay, so this will form our first relationship between the many different quantities. Okay, so using this, we're going to solve practice now 5. Okay, so let's look at practice now 5 in page 7. Okay, so so in a school there are 450 boys and 750 girls. Okay, alright, so calculate the percentage of boys and girls in the school. So straightforward, first one, so the percentage of boys, okay, percentage of boys, very easy, very straightforward. It will be just, okay, we want boys, so we put the number of boys here, and if there's nothing, right, percentage of boys just like that, it means we're referring to the total. So we put down the total, which is 450 plus 750, okay, times 100%. So pop this into a calculator. We have, okay, 450 over 750 plus 450. Alright, multiply by 100%, give us 37.5%. Okay, like this. Okay, next for part 2. Now, so the percentage of girls, because like it's very straightforward, it's like, do we need to do like this whole fraction thing? We can, or we may not need to. Okay, we just look at the total, okay, 100% minus of the percentage of boys, because it's just only these two cases. Okay, unless there are 3-4 genders, then yeah, then we will need to like do a bit more calculation. But if it's like either boys or girls, we can just minus straight away. So 100 minus this will be 62.5%. Okay, so let me repeat. So what we did here was we just take the number of boys, because we want to look at the number of boys, and the one that we are referring to will be the total number of students. Okay, and we multiply this by 100%. It's a fraction of 100%. Okay, like this. Okay, so this would be practice now 5, part 1 and part 2. Okay, let me pause for a while, and I need to rearrange and such that I will get practice now 6. Okay, practice now 6 over here. Okay, so let's go down. Okay, so practice now 6. Which is in page 10. Okay, we're jumping to page 10. Okay, so what's going on is okay, so we have the number of pages in magazine A, okay, and we have the number of pages in magazine B. Okay, so first question over here. Okay, so for magazine A, Okay, I'm writing down to like process this thing going on. So 128 pages. Okay, and in magazine B, we have 200 pages. Okay, sure. Okay, so the thing is, express the number of pages in magazine A as a percentage of the number of pages in magazine B. Okay, so what we want is, right, okay, the required percentage. Okay, the required percentage is, okay, we want to compare the number of pages in, okay, in magazine A. Okay, in magazine A, and we want to compare it to the number of pages in magazine B. Okay. Okay, so we have number of pages in magazine B, and we multiply this by 100%. Okay, so let's see, we have 128 over 200 multiplied by 100%. So what is this percentage? It is actually 64%. Okay. Alright, so number 2, same thing, but they're asking for how many percent is the number of pages in magazine B more than the number of pages in magazine A. So actually, it's just that, number of pages in B versus number of pages in A. Okay, and how much more is that? So if you're looking at how much more, the first way we can do is to find the difference. So the difference as compared to the number of pages in magazine A, so that will give us the percentage. Okay, or we can do this by just looking at the number of pages in B over A. I think that would be a bit more clearer. Okay, so actually up to you to do. You can find the difference, or for me, I'm just going to find the difference in percentage later. Okay, so the required percentage is, here I have the number of pages in A. No, we are looking for B, right? So B, and I want to divide by the number of pages in A, and I multiply this by 100%. Okay, so let's see how this works. So we have 200 over 128 times 100%. So 200 divided by 128 times 100%. Okay, so 624, 156.25. Okay, so this is an exact value, so I can just leave it like this. Okay, so the next thing is, because it's 156%, so it's actually 56% more. Okay, so the answer, the final answer is, it is, okay, 56.25% more. Okay, so this is the answer that we're looking for. Okay. Okay, then number two, we're actually looking for 1,400 ml as a percentage of 2.1 liters. So okay, so what the required percentage over here, okay, is we want our, okay, this amount of ml, right, as compared to 1400. Okay, so 1400 ml as compared to 2.1 liters, right, multiplied by 100%. Okay, now before we go on, before we calculate, right, we need to make sure that the two units that we compare are actually the same. Okay, so previously it was pages and pages, but here we need to change it either to ml or liters. So for me, I would prefer to change it to a smaller one, to change it to ml. So the 2.1 liters, right, is how many ml? It's just multiplied by 1000 to give me 2100 ml. Okay, and I will multiply this by 100%. So this is actually 2/3 of 100%, which is 66 and 2/3. Okay, percent. Now I'm writing this because this answer is in exact form. Otherwise, right, if I were to write in decimal, then it will go on forever and ever and ever. Okay, so which is not an exact form, and if we cut at like 66.7, it is actually rounding up to 3SF, which is not exact anymore. Okay, right, so this is practice now 6. So yep. 널 빌려 Okay, so practice now 7. Okay, so okay, so we have okay, practice now 7. Let me write this down. Okay, so practice now 7 is actually in page 10, if I'm not wrong. Okay, page 10. Okay, so what's going on here is Li Ting writes down a statement. If A is 20% more than B, then B is 20% less than A. So let's check whether is this true or not. Okay, so we're going to start with the if, then we're going to look at whether does it satisfy the then. Okay, so usually the logic is like this. So if A is 20% more than B, okay, so quantity A is 20% more than B, right? So we can write A is 120% of B. Now if we want to write it out in fraction, for me I want to like write out as a fraction to see whether is this statement true or not. So 120% is actually 6 over 5 or 1.2 of B. Okay, so I can write this. Okay, I can put down okay, I will just put 6 over 5 of B. Okay, now so then I want to check like B is 20% less than A, so I need to make B the subject. I need to like make it such that it will be B equals to something. So I need to remove the 6 over 5. So the denominator 5, because it's divided by 5, to reverse I need to multiply by 5, and multiply I can do this by doing a cross multiplication, right? 5 multiply upwards, then 6 I need to divide by 6, so I will need to divide by 6. So I will end up with actually 5 over 6A will be equals to B. Okay, because I divide by 6 and times 5, so I get 5 over 6A. Now this one, let me check out the percentage and see. So 5 over 6 times 100% of A is equals to B. And this one, right, let's see how it works. So 5 over 6 times 100, so this would be is over 3, so let me write in exact form. So this will be 83 and 1/3. Okay, 83 and 1/3% of A. Right, so B is 83 and 1/3% of A. So is it 20% less than A? Not really, it's less than that. Okay, so B is not. Okay, or maybe you can write that. I disagree. Okay, because B is not 20% less than A. In fact, it is less than that. Okay. Okay, so that's for practice now 7. Okay, let's look at a bit more. Okay, let's push a bit more. We have practice now 8 and 9. Okay, where we compare two different quantities and compare the proportion by calculating their percentages. Okay, so practice now 8 is ready. So let's go up. And, okay, let me write it down here. Okay, so practice now 8. Practice now 8, page 11. Okay, practice now 8, page 11. Alright, so we have okay, village A and village B. Which village had a higher proportion of people who attended its party? Okay, so by calculating the proportion as a percentage, it will be easier to find as compared to fractions, or okay, decimal may be easy, but percentages will be the most convenient way to find. Okay, so let's look at village A first. Okay, so for village A, okay, so the proportion is actually our 4,000 guests. Okay, and the total number of people is 30,000. And let's look at the percentage. So this will come up to 4 over 30 times 100. Okay, now I'm going to write this in decimal, because like okay, wait, actually I don't need. I can still preserve this in fraction, mixed number. So 13 and 1/3% of village A. Okay, next one for village B, it will be like this. 350, so 3,500. Total number of villagers is 25,000 times, alright, 100,000. So let's see, 3500 divided by 25000 times 1,000, no, 100%. So this is 14%. Okay, so which one had a higher proportion? So obviously village B has a higher proportion. Okay. Okay, like that. Alright, let's look at the last question of the day, which is in practice now 9. Yep, let's hold on for a while. Okay, now for practice now 9. So let's look at this thing over here. Practice now 9 in page 12. Okay, so the following table shows the amount of sugar found in each type of berry. So we have blackberry, blueberry, raspberry and strawberry with the mass of the fruit and the amount of sugar in each of them. So Cheryl's doctor advises her to reduce her sugar intake and advise Cheryl which of the berries has the lowest sugar content. Okay, so we will need to come and do this. Okay, so we just need to calculate the proportion of sugar, okay, in each berry. So actually it's just like, you know, sugar content or sugar proportion, right? Okay, in percentage, it's just the amount of sugar, okay, divided by the mass of the fruit. Okay, and then we just multiply by 100 because that is what we want as compared to the total thing that is given there, or what we're referring to. Okay, so let's look at the calculation. So for blackberry, okay, for blackberry we have okay, we just need to check again and see that the units tally. Okay, so 0.439 divided by 9 grams, all in grams. Okay, that's nice, times 100%. So we have 0.439 over 9 and 100. Now I'm going to write this in decimal because it will allow me to calculate easier. So what is, okay, it's a 7 repeating, so 4.88 SF percent, okay, in 3 SF. Okay, next one, blueberry. Okay, so for blueberry we have a 0.419 149, okay, over 1.5. So we have 100% over here, so we have like 0.149 over 1.5 times 100. Okay, we have 9.93333. So I'm just going to write this as 9.933. Significant figures should be good enough to compare. Next, raspberry. Okay, for raspberry we have 0.084 0.084 over 1.9, and we multiply this by 100%. Okay, so 0.084 over 1.9. Okay, so we have, oh dear, times 100%. Okay, so we're gonna have 4.42. Okay, so 4.42. That's a long list of repeating numbers though. Wow. Okay, can. Right. This, okay, why I can see this is because like this is a Vietnamese calculator. So yeah, okay. Strawberry would be, okay, 0.326, so 0.326 over 7 times 100%. Okay, our final one. Okay, so 0.326 over 7 times 100. Okay, so 4.66, so 4.66%. And all this, what I did was to round up to 3 SF. Okay, so to standardize, and it's easier for us to calculate and compare. So which of these berry has the lowest sugar content? Raspberry. Okay, 4.42 is the lowest. So therefore, raspberry, okay, has the lowest sugar contents. Okay, right, so this is the end of 8.1, so which is one long list of our knowledge from primary school, plus a little bit of calculation to help with the reasoning portion of this exercise. Okay, so yeah, so this is the end of the lesson. With the remaining time, what I want you to do is to attempt, okay, these two things. So we need to attempt exit pass 8.1a and actually 8.1b as well. Okay, so you have to finish up exit pass 8.1a and 8.1b, and I will go through it in the next day when we come back to school. Okay, so that's the end of this lesson. I hope you have a nice day, and I hope that this is a good refresher on what we did last time in primary school. Okay, so all the best. See you back in school. Right. Piano.